Hey everyone, welcome back to my channel. Today we're going to work on some algebra problems. So as you can see, we have three different quadratic equations to work on. But instead of just working on real numbers, or maybe we can extend to complex number as we usually do, we now have conditions that our solutions are actually limited in some integers. And in fact, we can only have solutions in the particular finite field. And if you don't know what a field is, doesn't really matter. I'll just briefly explain what those means. For example, when you say z11, it means that it will be the remainder after we divide by 11. So the possible solutions will be limited down to 0, 1, 2, so on and so forth until 10. Similarly, for z23, our limitation will be down to 0, 1, 2, all the way up to 22. All right, so here I'm going to show you guys a couple of different ways of doing this kind of problem so that you guys can actually try to think why it will work. And before we move on, you can pause the video and try yourself first. Done? All right, so let's take a look at the first one. So in the first problem, we're limited down to z11, meaning that as long as the two numbers or two integers have the same remainder after divided by 11, those two numbers are treated as the same number. Because of that, we can treat 11 or minus 11 to be equal to 0 because they both have the same remainder. So if we try to add 11 or subtract 11 on one side, we don't have to do it on both sides in this case because 11 or minus 11 is treated as 0. Therefore, here I'm going to subtract 11 on the left side only, which gives us the following. We still have x squared minus 5x, but now we have minus 3 minus 11, which means we have minus 14, which gives us 0. And now we can actually just factor out easily. And we can just use the cross multiplying. Since we want the sum be negative 5 and the product be negative 14, where the leading coefficient is just 1, we will just write 1 and 1. And then, since the product is negative, we want one of them to be negative. And we know the factors of 14 will be 1, 2, 7, and 14. So to pick up the negative 5, we need a negative 7 down here and a positive 2 up here. Good. Therefore, we can just write down our solution. X plus 2 times x minus 7 equals 0. And therefore, we'll be able to claim that x is equal to negative 2 or positive 7. But again, this is not done because in z11, negative 2 is not lying inside. How do we do it? Well, use the definition again. Since z11 is telling us the remainder after divide by 11, what is the remainder of negative 2 after divide by 11? 9, right, because we can just add 11 to tell what the remainder is. Therefore, x is equal to 9 or 7. And that's how we find our solution. Next one. We have z13. And we have x squared plus 2x equals negative 11. So what can we do? Well, of course, we can just move everything to one side to get x squared plus 2x plus 11 equals 0. And now as we think of this equation here, if it is an equation over the real numbers, as we usually do, we will notice that this is always going to give us positive solution, or this is always giving us positive value as we substitute any x value in. But then the right side is 0, meaning that there's no real solution, right? But when we are doing in finite fields such as a ZP, or in here we have Z13 for example, we don't have what's so-called positive or negative anymore. So we cannot just think it that way. Here is what we can do. We can try to think of -2 as the other way around, which is -11, because +2 as -11, excuse me, because they will have the same remainder. And therefore, we cannot we cannot say that this is always positive on the left-hand side. So how can we solve this problem? Well, we can actually use the quadratic formula and help us to get the result. But we need to be very careful. First, let's do it. By the quadratic formula, we will have x equals -b value, which is 2 in this case, plus or minus the square root of b squared, which is 2 squared here, minus 4a, which is 1, because the leading coefficient is just 1, times c, which is 11. Good. And then all divided by 2a, where a is just 2. So now we can actually try to simplify it. Let's see what we will get. As we simplify it, we need to be very careful on our division and the square root. So we will talk about those later. Let's do everything inside the square root first. We have 2 squared is 4, and then minus 4 times 11, which is 44. So we get -40. Okay. So should we just put an I here? Of course. No, we cannot do that because we're not doing with complex number. And keep in mind, here we say that the solutions are actually lying within 0 to 12. And if there's a number that are beyond that, we can just take the division and find out the remainder. So what can we do? We can actually try to find out the remainder of -40. And we know that 40 has a remainder 1 after we divide by 13. So -40 will be equal to -1. But what's -1 in Z13? Right. It will be +12. And again, what we can do is we just need to add 13 to turn it into positive and find the remainder parts. So what would be the square roots of 12? So we can still break it into what we usually do. It is the same as 2 squared times 3. So we can factor out the 2 and remaining the 3 here. So here comes the question. First, what is the square root of 3? We just need to go back to here, Z13, and we'll be able to find out. What should we do? Think of any possible number or any elements in Z13, and then try to square it and find out which result is equal to 3. For example, if we pick 0, if we square 0, we will end up with 0. If we pick 1, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. But since we're doing it in mod 13, we will just reduce it and then have to take the remainder 3. And here is one of the solutions. And of course, if 4 works, then -4 squared, which will also be equal to 16. It's going to be reduced to 3. And what's -4 again? -4 in mod 13 is equal to 9. So, in fact, the square roots of 3 can be rewritten as 4 or 9. And again, which case do we need? It doesn't matter, because if we look in the front, we have plus or minus. And that should make sense because, again, if we choose -4, that will give us 9. Or if we choose -9, it will give us 4 back. So we will end up with only 2 cases. So what can we do is, now we're going to factor out the 2 on top so that we end up with -1. And then we will write it plus or minus. Again, you can choose 4 or 9. And it will be easier if we choose a small number for us to calculate. Then we still have divide by 2. Now, are we allowed to do division here? It really depends. But in this case, we're allowed to do the division by 2 because 13 is a prime number, and as long as we're not dividing by any prime factor of this number in the ring, we'll always end up with a unique result, meaning that we don't have to worry about what we're dividing by as long as the number we're dividing by is not a factor of what is in the field. Okay, therefore, we can actually cancel out the 2 to end up with -1 plus or minus 4, which could give us either positive 3 or -5. And again, we should not have -5 as our answer because it's not part of the elements in Z13, or we want the remainder part to be lying between 0 to 12. So what should we do? Plus 13, as always. So that now the remainder is actually between 0 to 12. Therefore, we have our final answer. X equals 3 or -5 plus 13, which is 8. Good. Last one, we can do the same thing. So if we first try to put all the stuff on the left-hand side, we get 6x squared minus 19x plus 19x minus 7 equals 0. Then this is in fact factorable, or you can just use the quadratic formula if you want. So in this case, I'm going to use the first method again. If we try to factor it, we will get 3x minus 1 times 2x plus 7, which is equal to 0. So you may ask, we'll end up with x equals 1 over 3, and it will end up with fraction, right? So if you don't want to see fraction, what can we do here? Well, we can think of what the inverse of the leading coefficients are. And in fact, this is the same thing as what we would do even if we write as fraction. So it means that if we write as the following, we are now going to think of what is the inverse of 1/3. Or we shouldn't rewrite it as 1/3 because that's not the right notation. But we can write as this. 3 to the negative first power. And then the other one will be -7 times 2 to the negative first power. And again, that is a more formal way of writing it if we are dealing with finite field like this instead of just real numbers, because fractions doesn't really make sense in this case because there is no fraction in our elements or in our expression. So now we just need to find out the inverse of 3 and the inverse of 2, and then we'll be able to end our solution. But let's talk about the second one first. We can also try to rewrite -7 into some elements in Z23, so that will be easier. Why? Let's see. If we add 23 to -7, we will get 16 times 2 inverse. And we know that 16 is equal to 2 times 8. And again, this only works when the number right here in green is actually a prime number. And we'll actually talk about it next time why this has to be a prime number. Anyway, this is going to give us a reduction and end up with 8. So now we just need to figure out what is the inverse of 3 in Z23. So to find out what the inverse is, we're going to use the definition, meaning Suppose that the inverse exists. Let's call it value a here. Then if a is the inverse of what we are looking for, then the product will always be equal to 1. And in this case, since we're in Z23, we can also try to add multiple copies or subtract multiple copies of 23 in order to find out what that value of a should be. So in this case, let's try to add one copy of 23. This will give us 24, and we know that 24 is 3 times 8 times 8. Therefore, we know that in this relation, we know that a has to be equal to 8. And again, it only works when the green number here is actually a prime. So, in fact, 3 inverse is just equal to 8 here. So, at the end, we only end up with one solution. And it's a repeated solution. That's it. I hope you all enjoyed this video. If you think it is a cool idea, please don't forget to like. And you can also subscribe to my channel to find out more of my other videos, including other playlists and videos about other topics. And don't forget to turn on the notification so that you won't miss any of my new videos either. If you have any thoughts or idea, you can leave your comments down below. I'll see you guys in the next video.